So what is the first derivative test? So the first derivative test is pretty cool because it can be used, for one, to find the relative extrema of a function, and it can also be used to find where the function is increasing and where the function is decreasing. So how do you carry out the first derivative test? So if you're given f of x, sometimes you'll be given f prime of x from the start, but if you're given f of x, you first want to find f prime of x, or the derivative of f of x. And then you're going to find the critical numbers of f prime of x. So you're going to find the critical numbers of the derivative of f of x, which is wherever f prime of x equals 0 or it's undefined. So after you find those numbers, you're going to use them to make a sign chart, which is, it looks like this. It's like just a number line. So let's say we find that the critical numbers of f prime of x are 0 and 3, right? 0 and 3. We're going to make a chart like this, and we're going to fill it out, which I'll show you how to do in a minute. And all of the answers you need, all of where the relative maximums and minimums, and where all of the where f is increasing and decreasing, can all be found on the sign chart. So this is important. Okay, so here we're being asked to find the relative maximum, the relative minimum, and the intervals where f of x is increasing and decreasing. And this right here is f of x. So f of x equals 3x squared minus 2x plus 4. So the first step is finding f prime of x. So we want to find f prime of x, or the derivative of f of x. So we can use the power rule, and we go 2 times 3 is 6, and 2 minus 1 is 1, so 6x to the power of 1, minus 1 times negative 2 is negative 2, and then x to the power of 1 minus 0 equals, minus 1 equals 0, so that's going to be 1, so it's just 6x minus 2, and this has no x, so that just is out of the derivative. So f prime of x is equal to 6x minus 2. Looks right? Yeah, 6x minus 2. So now, with f prime of x, we're going to set it equal to 0 so that we can find our critical numbers. So 6x equals, flip this, 6x equals positive 2. So x equals 2 over 6. So x equals 1/3. So this is our only critical number, is x equals 1/3, because it's not going to be undefined anywhere. So we're only worried about where, because it's a polynomial, it's not going to be undefined anywhere. So we're only worried about where f prime of x is equal to 0. So f prime of x is equal to 0 at x equals 1/3. So this is going to be a pretty easy sign chart because we only have one number. So we're going to draw our number, or draw our line, and put 1/3. And then we're going to choose a number a little bit to the left of 1/3. So a little bit to the left of 1/3 we could do 0. And then we're going to choose a number a little bit to the right of 1/3, so we could choose something like 1. And then we're going to go back and we're going to plug in each of these numbers to f prime of x. So when f prime of x is equal to 0, when x is equal to 0, we would have 6 times 0 minus 2, so this is negative 2, but it doesn't matter that it's negative 2, all that matters is that it's negative, right? So this is negative. And then if we plug in 1, we get 6 times 1 minus 2, which is 6 minus 2, which is 4, which is positive. So here it's going to be positive. So this is f prime of x, and down here we'll do f of x. So this is negative infinity, and this is positive infinity. So when f of x is between negative infinity and 1/3, f prime of x is negative, which means, let's just pretend that this is the thing. If f prime of x is negative, that means the slope of the tangent line is negative, which therefore means that f of x, right here, is decreasing. So if f prime of x is negative, f of x is decreasing. So now we just found one of the things that we need to find. So we know where f of x is decreasing, And vice versa. If f prime of x is positive, that means the slope of the tangent line is positive, which means at that point f of x is increasing, right? So here f of x is increasing. And so now we just found where f of x is decreasing and where f of x is increasing. So now we have to find if there's a relative maximum or if there's a relative minimum. If there's both, we just have to find them. So a relative minimum, or here, I'll do this. A relative minimum would be a point like this, where f prime of x goes from negative, right, to positive. Or in other words, where f of x goes from decreasing to increasing. See, because this decreases and then it changes to increasing. So whenever that happens, we have a relative minimum. A relative maximum, on the other hand, is wherever f prime of x goes from positive to negative. Or in other words, where f of x goes from increasing to decreasing. So a point like this would be a relative maximum because f prime of x goes from positive, right, increasing, to negative, or decreasing. So 1/3, if at 1/3 f of x changes from decreasing, right, so it changes from decreasing to increasing, that would make this point 1/3 a relative minimum, right? So this right here is a relative minimum. And there's no relative maximums. There's no relative maximums because this function f of x never changes, or f prime of x never changes from increasing to decreasing. That would be a relative maximum, but since that never happens, since it never goes from increasing to decreasing, we have no relative maximums. So now, let's erase this work and keep our sign chart. So now we could write statements because we have all of our information. So our first statement, let's start with relative minimum. So we would write f of x, right, our function, has a relative minimum, and abbreviations like this are accepted on the AP test. So you can write relative minimum. So f of x has a relative minimum, right, because decreasing to increasing, relative minimum, at x equals 1/3 since, or because, since f prime of x changes, right, that's important, because at any relative max or relative min, f prime is changing. In this situation, it's changing from negative to positive. So since f prime of x changes from negative to positive. So that's our statement for relative minimum. Now, I'm not going to write the statement for increasing and decreasing because they're the same, just opposite. So I'll just do decreasing. So you would write f of x, our function, is decreasing. You can write just dec, period, that's accepted on the AP test. F of x is decreasing on, because I asked for an interval, so it's decreasing on negative infinity to 1/3, right? Negative infinity to 1/3. Because all of this from negative infinity all the way up to 1/3 is, or f prime is negative. So that means that f of x is decreasing when f prime is negative. So f of x is decreasing on negative infinity to 1/3 since, right, since f prime of x is negative. So because f prime of x is negative, that means f of x is decreasing. And then for the increasing statement, it's the same thing. We would write f prime of x is, f of x is increasing on 1/3 to positive infinity, since f prime of x is positive on that interval. So it's increasing. Okay, here's a practice problem. You can go ahead and pause the video and do it on your own if you want to. But this time, make sure you note that we're given f prime of x rather than f of x. So the first step is not finding the derivative because we already have the derivative. Okay, so we're given f prime of x equals negative 2x times x minus 3 squared. And they want us to find where f of x is increasing, where f of x is decreasing, and where f of x has a relative maximum, and where f of x has a relative minimum. So, let's start by finding the critical numbers of f prime of x. So we're going to do that by setting f prime of x equal to 0. So negative 2x times x minus 3 squared equals 0. So we could try to solve all this algebraically, but I think it's going to be quicker and easier if we just look at it and find where this is going to equal 0. What number can we plug in for each of these x's that's going to make this equal to 0? So first, we start here with this negative 2x on the outside. And we can see that if we plug in 0 for x, then it's going to be negative 2 times 0, which is 0. So 0 times whatever this is going to be is still going to be 0. So we know that when x equals 0, we have a critical number, right? Because if we plug in 0 here, this is going to be equal to 0. So f prime of x is going to be equal to 0. And another critical number is going to be 3, because if we plug in 3 right here, 3 minus 3 equals 0. 0 squared times anything, so 0 times anything is 0. So we also know that this is going to be equal to 0, so f prime of x is going to be equal to 0 if we plug in 3 for x. So these are our two critical numbers. So now the next very important step is setting up our sign chart. So let's make some room. We know that our critical numbers are x equals 0 and x equals 3. So critical numbers are x equals 0 and x equals 3. So now, with our sign chart, we're going to plot 0 and we're going to plot 3. And now we're going to choose a number for each of these spaces. So for a number that's slightly to the right of 3, let's choose 4. For a number that's in between 0 and 3, let's choose 1. And for a number that's to the left of 0, we can choose something like negative 1. And now we're going to go and we're going to plug in each of these numbers into f prime of x and find if the output is negative or if the output is positive. So if we start with negative 1, we plug in negative 1 here, that's going to be 2 times, and this is always going to be positive because it's squared. So negative 2 times negative 1 is positive times positive. So between negative infinity and 0, f prime of x is going to be positive. Now, between 0 and 3, we chose 1, so let's plug in 1. We already know this is going to be positive because anything that's squared is positive. So we're going to have positive times negative 2 times 1, which is negative. So this is going to have a negative output. Finally, let's plug in 4. So we know this is going to be positive because it's squared. And negative 2 times positive 4 is negative 8, so this is going to have a negative output if we plug in 4 to f prime of x. So, if f prime of x is positive, what does that tell us about f of x? It tells us that f of x is increasing, right? Because, let's pretend this is the graph. If f prime of x is the slope of the tangent line, let's go to this point for example, slope of the tangent line right here is positive. So, slope of the tangent line, or f prime of x, is positive, which means at that point f of x, right, this is f of x, is increasing. So if the slope of the tangent line, or f prime of x, is negative, then that means f of x is decreasing. Same here, f of x is decreasing. So now we have almost everything we need, and we have to remember it's also asking for where f of x has a relative maximum and a relative minimum. So to find where we have relative maximums and relative minimums, we're going to find where f prime of x goes from increasing to decreasing and where it goes from decreasing to increasing. So if it goes from increasing to decreasing, we have a relative maximum. If it goes from decreasing to increasing, we have a relative minimum. So we're going to find where f of x is either going from increasing to decreasing or decreasing to increasing. So f of x goes from increasing to decreasing, right? Increasing to decreasing at 0, which means we have a relative maximum. So at 0, we have a relative maximum. Okay, boom, we found one of our relative maximums. And now let's go to our other critical number, 3. At 3, it goes from decreasing to decreasing. So what does that mean? What that means is that at 3, it goes up to 0, right? We know that because f prime of x equals 0 at 3, because it's a critical number. So at 3, it goes up to 0. So that means the tangent line becomes flat, but it doesn't change. It goes from decreasing to decreasing. So it may look something like this, for example, if the function goes like that, right? But let's pretend that's perfectly flat. The tangent line, or it is increasing, it's increasing, it's increasing, and then it goes to flat, or 0. Let's say this is 3, right? So at 3, it goes to a flat tangent line, so f prime of x equals 0, and then it goes back to increasing. So it changes from increasing to increasing, except there's a slope of 0 in between. So this is not a relative maximum or a relative minimum, it's just a horizontal tangent line. So we can erase that. And now we can start with writing our statements. So, where is f of x increasing and decreasing? Let's start with that. So f of x is increasing on the interval negative infinity to 0, right? It's increasing on negative infinity all the way up to 0, right? It's increasing. Since, right, we have to explain, since f prime of x, or the slope of the tangent line, is positive. It's increasing because the slope of the tangent line is positive, which makes sense, right? Next, let's write our statement for decreasing. So, f of x is decreasing on 0 to 3 and 3 to infinity. Whoa, not a great infinity there. On 0 to 3 and 3 to infinity. So this u just means and, right? It's decreasing on these two intervals, right? On this interval and this interval. Or it means like union, so these are together, but basically just means and. So why couldn't I just have written f of x is decreasing between 0 and infinity, right? Because it goes from decreasing to decreasing. The reason you have to separate these, it's decreasing between 0 and 3 and between 3 and infinity, is because at 3, f prime of x equals 0. So the slope of the tangent line, is 0. Just pretend that's a flat line. The slope of the tangent line is 0. So it's not increasing at 3. So that's why we have to exclude 3. So now let's explain. F of x is decreasing on 0 to 3 and 3 to infinity, since f prime of x, or the slope of the tangent line, is negative on these intervals. So now we have our two statements for increasing and decreasing, so you can check if you got that right. Next, let's move on to writing our relative maximum and relative minimum statements. So the relative maximum and relative minimum statements are also pretty much the same, just opposites. And they all follow the kind of the same structure, all four of the statements. It's just f of x is this because this. So now let's write our relative maximum and relative minimum statements. So f of x has a relative maximum at, right, instead of on, now it's at because it's at a singular point. So it has a relative maximum at x equals 0. At x equals 0. Now I have to explain. Since f prime of x, or the slope of the tangent line of f of x, changes, that's important, it changes from positive to negative. So we're saying f of x has a relative max because, just pretend that that's the graph of this. F of x has a relative max at x equals 0, since f prime of x, or the slope of the tangent lines of f of x, changes from positive to negative. So there's a relative max at x equals 0. And now for relative minimum, our relative minimum statement, since we have no relative minimums, right, we have no relative minimums, all we're going to write is f of x has no relative minimums since f prime of x never changes, right? Never changes from negative to positive. So because because f prime of x, never changes from negative to positive, we have no relative minimums. This never happens on this graph, or on f of x. This is the derivative of f of x, but this never happens on this graph f of x.